Hello and welcome to the Science for Sleep Hub, that quiet corner of the internet where the universe slows down just enough for you to breathe, where curiosity finds peace, and where science's greatest ideas are told in the soft voice they deserve. Tonight, we'll ask a question that seems simple at first, but then quietly grows until it becomes almost impossible to keep in your mind. How big is the universe compared to our own galaxy? The Milky Way, even from where we stand, feels impossibly vast. And yet tonight, we'll discover that the Milky Way, with its hundreds of billions of stars, is just the first step on a staircase that stretches far beyond what we can easily imagine. What you're about to hear are truly astonishing facts. Before we begin, I'd like to ask you something simple. Where are you listening from tonight? Have you settled into a warm and cozy corner where the day is behind you? Wherever you are, I'm glad you're here and that you've chosen to drift off to sleep with us. And if this journey we're taking across scale and distance helps slow your thoughts and reminds your body how to rest, I'd be very grateful if you'd like this video or subscribe to the Science for Sleep Hub. It helps ensure this quiet corner reaches others who need it as well. Now, if you'd like, you can close your eyes. Let your shoulders relax. Let the weight of the day slowly slip away from you. Tonight, we'll measure something together, not with a ruler, not with numbers that don't mean much on their own, but through the gentle expansion of our imagination, with careful steps, one by one. And while we do this, you don't need to be anywhere else. Let's start our journey right where you are. You're sitting or lying on the surface of a small rocky planet. This planet orbits an ordinary star we call the Sunday. And this star, along with everything around it, planets, moons, comets, and silently drifting dust, belongs to something much larger, a galaxy, the Milky Way. The Milky Way is a massive, rotating disk composed of stars, gas, and dust, with long, winding arms that resemble a flattened pinwheel. If you could somehow rise high enough to see its entire shape at once, you would see a bright, dense core at the center, with spiral arms curving outward from it, glowing faintly with the light of countless stars. Our galaxy contains between 100 and 400 billion stars. Astronomers do not know the exact number, and this uncertainty alone is worth pausing to consider. We cannot count them one by one. We can only estimate based on the galaxy's total mass and the types of stars we observe in our vicinity. Even our most precise instruments cannot provide an exact figure for what we call home. From one edge to the other, the Milky Way's disk spans approximately 100,000 light-years. A light-year, as you probably know, is the distance light travels in one full year, moving at a speed of about 300,000 kilometers per second. If you were to try to cross the Milky Way at the speed of light, the fastest speed anything in our universe can travel, the journey would take 100,000 years, not 100,000 kilometers, not 100,000 days. At the fastest speed permitted by the laws of physics, 100,000 years. That's a mind-boggling scale, and yet there is a strange comfort hidden within that number. Tonight, you don't have to feel the weight of 100,000 years. It's enough just to feel the gentle truth beneath it, the truth that the place you call home is so vast that even the very idea of leaving it would make it seem small. And yet, within all this immense expanse, gravity has patiently held everything together for more than 13 billion years. So where exactly are we within this vast disk? Neither at the center nor at the edge, but somewhere in between on one of the spiral arms, about 26,000 light-years away from the galactic core. Our Sun, and the small, rocky planet you're currently lying on, completes a full orbit around that distant core every 225 to 250 million years. The last time we were roughly in this same position, dinosaurs hadn't yet appeared on Earth. But the Milky Way isn't just that bright disk we can imagine. Surrounding that shimmering spiral is something much larger and almost completely invisible. A roughly spherical halo made up of old stars, faint star clusters, and a massive amount of matter we can't see at all. Astronomers call this invisible matter dark matter, and it may even be more massive than all the stars in the galaxy combined. This halo extends far beyond the visible disk, reaching a width of perhaps 300,000 or 600,000 light-years. It is several times wider than the glowing spiral we imagine when we think of our galaxy. In other words, the Milky Way you picture, with its bright arms and golden core, is enveloped in darkness on all sides. It is, in fact, only the small, visible part of something much larger and much quieter. And yet, even this massive halo is not alone in space. The Milky Way has companions, smaller galaxies, caught in its gravitational pull, slowly orbiting us just as moons orbit a planet. The largest of these are the Large and Small Magellanic Clouds, which can be seen as faint patches of light from the southern hemisphere and drift about 160,000 light-years away from us. The Milky Way is not just a galaxy floating in empty space. It is the largest member of a small group of galaxies, known as the Local Group, a loose cluster of more than 50 galaxies held together by mutual gravity, drifting through space like a cosmic neighborhood. Most of these companion galaxies are small and faint and can easily be overlooked, but one of them is anything but small. That galaxy is Andromeda, and it is the Milky Way's twin in almost every respect. Andromeda's disk spans more than 220,000 light-years in width, more than twice the size of our own galaxy, and can contain up to 1 trillion stars, several times more than the Milky Way. On a clear, dark night, far from city lights, you can see it with the naked eye. It is a faint, soft patch hanging quietly in the constellation that bears its name. The light leaving Andromeda tonight, which you could see if you went outside and looked up, began its journey 2,500,000 years ago. When that light first set out, our species did not yet exist. According to scientists, our earliest human ancestors had only just begun walking across the plains of Africa. That light has traveled patiently and ceaselessly throughout all of human history, just to reach this very moment, this very sky, and you. And Andromeda isn't standing still. It's slowly approaching us, crossing the dark void between us, at a speed of about 110 kilometers per second. In about 4 billion years, our two galaxies will begin to merge, not violently, as you might imagine, but gently, over hundreds of millions of years. As the stars silently pass by one another in that vast expanse of empty space between them, astronomers have already given this galaxy of the distant future a name: Milkomeda. Let that sink in for a moment. The galaxy you'll see with your own eyes tonight, that soft patch of light in the sky, is more than just a neighbor. In a sense, it is the future itself. Long before either of us existed, a slow merger already underway was woven into the movements of these two galaxies. But the Milky Way and Andromeda together, as vast as they are, make up only a small part of the local group. Beyond them lie the smaller Triangulum Galaxy and dozens of dwarf galaxies scattered around the two giants like silent servants. The entire local group spans roughly 10 million light-years, 100 times wider than the Milky Way's own glowing disk. We've already expanded our perspective 100-fold, and we're still just at the very beginning of the journey. Take a moment here to let your breath slow down. There's no need to rush to the next level of scale. The universe has been patient for 13 billion years. Tonight, too, as you rest within this first expansion of your perspective, before taking another step outward, it can be patient with you. Now take a step back and witness how even the local group itself has become just a small cluster among many. Galaxies, it seems, almost never exist in isolation. They gather in groups, and those groups, in turn, come together to form something even larger. The massive clusters that astronomers call superclusters, which stretch for hundreds of millions of light years. The local group, along with our nearest large neighbors, is part of such a structure. We call this the Laniakea supercluster. The name, derived from the Hawaiian words for sky and boundless, simply means boundless sky. It's a fitting name. Laniakea spans approximately 520 million light-years and contains the combined mass of about 100,000 galaxies. Within this supercluster, galaxies are not scattered randomly. Like water finding its own path down a slope, they flow along invisible rivers of gravity toward a distant, massive concentration of matter known as the Great Attractor. Our own galaxy, along with everything in the local group, is being slowly drawn in that direction by a force so vast and gentle that we cannot even perceive it. For a moment, try to hold this in your mind gently, without forcing it. The Milky Way, which once felt to us like the entire universe, is now just a tiny thread within a vast cosmic river, just one of hundreds of thousands of galaxies moving together through the darkness. And yet, even Laniakea is not the final boundary. Superclusters are connected by long, thin galaxy filaments that stretch like threads in a vast, three-dimensional web throughout the cosmos. Between these filaments lie vast, nearly empty regions known as cosmic voids, where almost nothing exists, some of which extend for hundreds of millions of light-years. We call this vast pattern, formed by filaments, clusters, and voids, the cosmic web. If you could rise high enough to see everything at a glance, the universe would not look like a collection of randomly scattered points. It would look more like something that has grown like the branching roots of a tree, or the delicate, shimmering structure of neurons inside a living brain. Somewhere within that vast, woven structure, hidden among countless other threads, on a silent thread, lies the Milky Way. And within the Milky Way, hidden in a quiet arm, just one of many, there is a small yellow star. And orbiting that star is a small rocky planet. And on that planet, right now, you are breathing slowly, listening, gently held within a structure so vast that no mind could ever fully imagine it all at once. We are now ready to ask the question we started with, but with a much better understanding of what it actually means. How big is the universe compared to our galaxy? We have already expanded our perspective from a single galaxy to a group of 50 galaxies, and then to a supercluster of 100,000 galaxies. And yet, we were still describing just a single neighborhood within something even larger, the observable universe itself. The observable universe is the name we give to everything we can see from Earth. Since the beginning of the universe, approximately 13.8 billion years ago, it includes every galaxy, every supercluster, and every filament of the cosmic web whose light has had enough time to reach us. And its size is so vast that it is almost impossible to describe. Because space itself has been expanding during this time, the observable universe is not, as you might initially expect, only 13.8 billion light-years across. It is much larger, roughly 93 billion light-years from one edge to the other. To cover that single distance, the Milky Way, which is 100,000 light-years wide, would have to be lined up side by side nearly 1 million times. Let your body rest for a moment with this number. If 1 million Milky Ways were lined up end to end, they would span the observable universe just once. And our galaxy, with its hundreds of billions of stars, its ancient halo, and its slow rotation in space, is just one of those million repetitions, a tiny part of a pattern that stretches so far beyond that no eye could ever follow it. And within that observable universe, scientists estimate there could be between 200 billion and 2 trillion galaxies. On average, each one contains hundreds of billions of stars. It is estimated that the number of stars in the observable universe alone is around 1 septillion, 1, followed by 24 zeros. This number is so large that it no longer really means anything. It simply becomes a kind of concept. This feeling doesn't have to be overwhelming. It can simply be a sense of wonder, the quiet, settled kind that comes just before sleep, when the mind stops trying to hold on to every detail and simply rests within the form of something boundless and beautiful. Let's return for a moment to the comparison we were about to make. The Milky Way is 100,000 light-years wide. The observable universe is roughly 93 billion light-years wide. If you were to shrink the Milky Way to the size of a single coin resting in the palm of your hand, the observable universe, on the same scale, would be wider than the entire distance from Earth to the Sun, repeated many times over. Here's another way to put it. If the Milky Way were the size of your front door, the observable universe would be roughly the size of the entire Earth. Although our galaxy is vast, shimmering, and filled with hundreds of billions of stars, on the scale of all that exists, it's smaller than a single doorstep. And even this figure, 93 billion light-years, describes only the part of the universe that we can see. Because space is constantly expanding as light travels toward us, there are regions of space from which light will never reach us, not because they are too far away, but because the space between us is expanding faster than light can travel through it. This means that beyond the 93 billion light-years we can observe, there are definitely more universes. Perhaps many more, perhaps we could even speak of infinity. Always beyond our reach, always beyond the reach of any telescope we could ever build. We are not looking at the edge of everything. We are simply looking as far as light can carry its message to us, for as long as the universe has existed. Let this thought rest gently beside you as you drift along. Beyond even the farthest galaxy we will ever see, the universe simply goes on unobserved, unmeasured, unknown, but by no means any less real, any less filled with its own silent galaxies and its own slowly rotating stars. Tonight we began with a single galaxy, the one you call home. Now we've traveled outward, passing through a dark matter halo, a small family of 50 galaxies, a supercluster of 100,000 galaxies, and an observable universe capable of containing 2 trillion galaxies. And yet, this is only the first part of tonight's journey. In the next chapter, we'll look even further toward the question of what might lie beyond the entire observable universe, toward the very limits of just how vast all of existence might truly be, and toward the strange, quiet comfort of being so small within something so vast. But for now, keep your eyes closed. Together, we continue to slowly expand our perspective from a single galaxy to a dark matter halo, to a small family of 50 galaxies, to a supercluster of 100,000 galaxies, all the way to an observable universe capable of containing 2 trillion galaxies within itself. Let your body settle back into the place where you are resting. We will continue to drift outward. Before you continue, take a slow breath in and exhale even more slowly. There's nothing you need to remember beforehand. Every number tonight, just like light passing through clear water, can simply pass through you, leaving behind only a feeling, not a fact to hold on to, but a sense of scale. By the end of the first chapter, we had reached the edge of what we call the observable universe, the farthest distance from which light has had time to travel toward us since the universe began, roughly 93 billion light-years. But beyond that boundary, a question naturally comes to mind, the kind of question that tends to surface in that quiet space just before sleep, where curiosity and rest overlap. What is actually beyond the edge of what we can see? If you want an honest answer, this is something we don't know for sure. But this uncertainty doesn't mean there's a void. The edge of the observable universe is not a wall, nor is it the edge of existence itself. It is simply the edge of our knowledge, the farthest point from which light has had time to reach us. Beyond it, space certainly continues, filled with galaxies whose light is still on its way to a future Earth that does not yet exist. For a moment, imagine standing in the middle of a calm, dark sea at night, holding a small lantern in your hand. The light from your lantern reaches only a certain distance before fading into the dark water around you. That fading edge is not the edge of the sea. It is simply the edge of what your lantern can show you. The sea continues, calm and boundless, far beyond the reach of your small light. Cosmologists have given that light a name. They call it the cosmic horizon. And just like the horizon you can see from a beach during the day, it moves with you. It is not a fixed boundary in space. Rather, from any given location, it is the limit of how far back in time the light allows us to see. If there were another small, rocky planet orbiting another ordinary star, far beyond our own horizon, an observer standing there would have their own cosmic horizon, extending 93 billion light-years in every direction from where they stood. Their horizon would overlap with ours in some places, and extend into regions we could never see, just as ours does for them. In other words, every point in the universe lies at the center of its own observable bubble. It is a unique position, with no single, objective center from which everything is measured. The Earth is not at the center of the universe. The Earth is simply at the center of its own unique view of the universe, a view that any other observer anywhere else would have that is equally complete and accurate for them. If you let yourself go, there is something quietly soothing about this thought. You are not on the edge of anything. You are not in some forgotten corner of existence. Wherever you happen to be right now, in the truest geometric sense, you are exactly at the center of your own observable universe, just as every other point in the cosmos is at its own center. So we know what lies just beyond our horizon, definitely more of the universe, filled with galaxies similar to those we've already encountered tonight. But beneath this lies a deeper question. Does the universe go on forever, or does it eventually come to an end somewhere? This is one of the oldest questions in human thought, and it remains truly unresolved. Cosmologists have used the faint, lingering glow of the universe's earliest light to measure the overall shape of space itself, and the results suggest something extraordinary. As far as our instruments can tell, space appears to be flat, not curved in on itself like the surface of a sphere, nor curved outward like the surface of a saddle, but flat, just as a vast, infinite sheet of paper might be. If space is truly flat and remains flat without ever changing, the simplest mathematical conclusion is that the universe extends infinitely infinite in every direction, boundless, centerless, and with no point where space simply stops. An infinite number of galaxies, an infinite number of stars, repeating endlessly outward. This is a reality that is unimaginably vast and mind-boggling. It's worth pausing for a moment to reflect on that word. Infinite. Not just very large, not larger than we can count. Truly, mathematically, infinite. If this is true, then somewhere beyond anything we could ever observe, to an unimaginable degree, there could be another galaxy almost identical to our own, and another, repeating in patterns so distant they could never be compared. But there is another possibility that is equally serious and equally well considered. Space may be flat on the scale we can measure, but it may still be finite overall, so vast and smoothly closed in on itself that we cannot detect it from where we stand. Imagine the surface of a balloon. If you were a tiny creature living on that surface, able to see only a small portion of it at a time, the balloon's surface would appear essentially flat to you, even if it were curled back onto itself on the largest scale. If the universe were shaped like that balloon, it would be finite. Even if it were unimaginably large, it would still have a definite, measurable size. And yet, it would never have an edge you could reach, or a center where you could stop. In principle, you could travel along a single straight line for a sufficiently long time, and eventually, having circumnavigated the entire universe without ever turning around, you could return to where you started. Our current measurements cannot completely rule out either possibility. Within the limits of the precision of our instruments, if space is curving in on itself, this curvature must be so subtle and the universe so vast that the effect is essentially invisible to us, hidden beyond the limits of what we can measure today. This means that tonight, as you drift off to sleep, you may be allowed to gently hold both possibilities side by side without having to choose between them. An infinite universe repeating endlessly, or a finite universe so gently curved that it feels infinite from within. In either case, the practical reality unfolding for you right here, right now, is the same. From where you stand, the universe might as well be infinite. Before we venture even further out into the cosmos tonight, there's one more idea worth pondering, a quieter, stranger possibility that some cosmologists take seriously. What if our entire observable universe, with its 2 trillion galaxies and 93 billion light-years, is nothing more than a single tiny bubble, floating among countless other bubbles, each of which is its own separate universe, each perhaps governed by its own specific laws of physics? This idea is generally referred to as the multiverse, and it naturally arises from certain models of how the universe began, models that describe a process we call eternal inflation, in which the rapid expansion that gave life to our universe does not come to a complete halt anywhere, but instead continues indefinitely within a larger, surrounding space, constantly giving birth to new universes, each expanding outward to form its own observable cosmos. If this picture is correct, the universe we discovered tonight, even though it already feels so boundless, would be just a single bubble among countless others, each its own complete cosmos, with its own galaxies and slowly rotating stars, separated from ours forever by distances so vast that describing them in terms of ordinary space might not even make sense. It is important from the perspective of space science to clearly state that the multiverse is still a hypothesis, not a proven fact. There is no direct way, at least for now, to observe another universe or to test whether one actually exists beyond our own. Some scientists view this idea as a natural and elegant consequence of well-tested physics. Others see it as going a step beyond what science currently claims to know. Both views are defended by serious, careful researchers, and the question truly remains open. And if I may, there's something gentle about that openness. Not every question tonight needs an answer before you go to sleep. Some questions are simply meant to be carried quietly, not because you have to solve them, but because they're pleasant to hold, like a smooth stone you can carry in your pocket. Let's gently turn our attention back to something we can measure with far greater confidence. Whatever lies beyond our cosmic horizon, whatever the true shape of the universe may turn out to be, within our own observable universe, we know with absolute certainty that matter is not evenly distributed. It is gathering, it is clustering. It forms the vast cosmic web we discovered earlier, galactic filaments stretching across unimaginable distances, separated by vast, nearly empty voids. Some of these voids are so vast that their size is beyond comprehension. One of the largest known voids, sometimes called a supervoid, contains far fewer galaxies than the surrounding regions of space and stretches for roughly 1 billion light-years, a vast, silent desert in the structure of the cosmos, where the universe simply has less to show. If you were somehow placed inside one of these supervoids, far away from the nearest galaxy, the night sky above you would appear almost completely empty, a darkness that feels different from ordinary darkness, because it would be devoid of the faint, diffuse light from the countless distant galaxies that fill our own sky, galaxies we never consciously notice, but that are quietly there. Fortunately, our own galaxy is located in a much richer neighborhood. It belongs to the Milky Way local group, which in turn belongs to Laniakea, which lies along one of the denser filaments of the cosmic web, and because it is close enough to other galaxies, even though our night sky appears calm and quiet to the naked eye, it is actually densely packed with light, much of which is too faint or distant for us to detect without a telescope. Let your thoughts rest on this for a moment. Even on the quietest, most empty-feeling night, the sky above you is never truly empty. It is quiet, only in the way a library is quiet, filled with knowledge, filled with distant light, filled with galaxies patiently sending their stories through the darkness, waiting only for something or someone willing to listen. Tonight, we journeyed outward from a single galaxy, passing through every scale of structure we understand: groups, superclusters, the cosmic web, the observable universe, and the open, unresolved question of whether there is truly anything beyond it. Now might be a good moment to turn our attention back inward, gently, to something a little easier to hold in our minds, back to our own galaxy, and that strange, silent question of exactly how it fits in with everything we've described, in honest, numerical terms. To put this comparison into a more relatable perspective, if we were to shrink the entire observable universe down to the size of Earth, the Milky Way, on the same scale, would be smaller than a single grain of sand on a beach surrounding the entire planet. Smaller than a grain of sand on an Earth-sized beach. That is the true relationship between what you call home and what we measured tonight. And yet, that single grain of sand contains hundreds of billions of stars, an unknown number of planets, and at least one small world, a world that, over billions of years, has been so carefully arranged that matter itself, lying silently in the darkness, will listen to a voice describing its own extraordinary scale, and find the whole idea not frightening, but comforting. There is no contradiction between being small and being meaningful. These two things have never really been connected. A grain of sand, if you look closely enough, can hold within it the patience of an entire ocean, and, it seems, so can you. If your shoulders have become a little tense while traveling these distances, let them relax again. None of these numbers were meant to be carried like a burden. They were meant only to be felt briefly, like a passing breeze, before settling back into the simple comfort of your own breath, right here, in this small and meaningful place, right now. In the next part of tonight's journey, we'll take a closer look at the strange, almost paradoxical relationship between something being unimaginably old and, in cosmic terms, something being brand new. We'll explore how the light reaching you tonight is, in a very real sense, a message from the deep past, and what that means for our understanding of time itself, as it unfolds across the scale we'll be exploring in this segment. But that's a story for another time. For now, just let yourself rest within everything we've measured together. A galaxy containing hundreds of billions of stars, a halo of dark matter, a family of 50 companion galaxies, a supercluster of 100,000 galaxies, an observable universe containing 2 trillion galaxies, and beyond it all, a question that remains gently and peacefully unresolved. I hope your thoughts continue to drift gently outward, and then, just as gently, drift back inward towards sleep. Whatever form the universe actually takes, as long as you continue this journey with us, it will be exactly this vast and exactly this patient. Tonight, We journeyed from a single galaxy, through dark matter, through a galaxy cluster, through a supercluster, to the very edge of what we can observe, and to the open question of whether the universe ever ends. In the final episode, however, we'll look at something a little different, not space, but time, and that strange, gentle path where the two silently become one. Let your body settle completely, wherever it is resting right now. Tonight, there is nowhere left to go but inward, toward rest, and one last time, a little further outward, toward the deep past carried within every point of light upon you. There is something worth pausing to consider and reflect on. Light does not travel instantaneously. It moves at a constant, finite speed, fast, but not infinitely fast. This means that when you look at anything, even something as close as your own hand, you are, technically speaking, seeing it slightly in the past. During that brief moment, it takes for the light to travel from your hand to your eyes. For you, that delay is so small, it's imperceptible, a tiny fraction of 1 in a billion. But the same simple rule applies at any distance, and as the distance increases, so does the delay, until it becomes something you can actually feel if you allow yourself to. Look at the moon on a clear, calm night, and you see it as it was about 1.5 seconds ago with almost no delay, more like a whisper than a true gap in time. Look at the sun, and you see light that left its surface roughly 8 minutes ago, traveled the 93 million miles between us, and finally reached your eyes. Look at the nearest stars beyond our own sun, and the delay stretches into years, 4 years for the closest one, called Proxima Centauri. If you had glanced in its direction, the light reaching your eyes tonight would have left that star 4 years ago, while you or someone very much like you were already living an ordinary life on this very planet. And as we discovered long ago tonight, that soft, faint patch in Andromeda carries light that is 2,500,000 years old, older than our entire species. A message sent long before anyone existed who could write it down, remember it, or wonder, as you are wondering right now, where it might have come from. This implies something profoundly silent about the night sky as a whole. When you look at the stars, you are never seeing the universe as it is right now. You are looking at a vast collection of ancient messages layered into a single sky, messages that come from a moment in the past, yet feel completely simultaneous to our eyes. A star in one corner of the sky may be sending you light from 1,000 years ago. The star right next to it, which appears just as bright and just as close, may be sending light from 10,000 years ago, or even 100,000 years ago. Just by looking, there's no way to tell how old each point of light actually is. The night sky is not a snapshot. It is more like a silent archive. The deeper astronomers look, the deeper into that archive they can peer. Our most powerful telescopes have managed to capture light that left its source more than 13 billion years ago. Light from the first galaxies, sent out into the darkness when the universe itself was still very young, only a few 100 million years old. To look at one of these ancient galaxies is, in the truest sense, to look directly into the deep childhood of the universe. It is not a memory of it, nor a reconstruction of it, but real, physical light that was emitted from its surface back then, traveling uninterrupted for 13 billion years, making its way solely to reach the interior of a telescope that would be built billions of years later by creatures yet to come into existence. There's an old, somewhat poetic expression that astronomers sometimes use without giving it much thought anymore, because it's become such a commonplace part of their work. They call telescopes time machines. And that's really no exaggeration. It might be the only sentence in all of astronomy that's literally true. This means that the cosmic horizon we discovered earlier tonight, the edge of the observable universe, located 93 billion light-years away, is not just a distance limit. It is also, quietly, a time limit. We are not merely looking as far as light can reach. We are looking back as far as light can carry us to a version of the universe so young that it has not yet fully cooled since its own birth. If you could somehow stand right at the very edge of what we can observe, looking in the direction where our telescopes detect the oldest light, you would, in a sense, be looking at the birth of the universe. Not symbolically, literally. The actual photons reaching that point would be the very same photons emitted in the earliest moments of the universe after a 13 billion-year journey, finally completing the longest journey light has ever taken. Woven gently into all of this is a kind of silent assurance about your place in time. You're not arriving late to the universe. You're not missing an earlier, more interesting chapter. In the most literal sense, you're living right on the very edge of everything that has happened so far, the freshest moment possible, standing atop 13.8 billion years of accumulated history. Every star you look at, every galaxy we're measuring tonight, every photon currently completing its long, patient journey toward Earth is racing toward this very moment, eager to reach you, stretching out toward you, right here. In a strange and gentle way, the entire history of the universe has been quietly orchestrating itself to reach this very point in time, the moment you're listening to right now. Let this sink in for a moment, just as the deepest feelings of relief usually need a moment to settle in. You are not small and forgotten in an indifferent universe. In a very real sense, you are the place where light, having traveled 13.8 billion years, is now, silently, arriving. Tonight, throughout this entire journey, we've moved outward across every scale we currently understand. A galaxy, a halo, a small family of companion galaxies, a supercluster, the observable universe, and whatever lies beyond it, with its open, gentle mystery. And we have moved backward through time itself, tracing the ancient light of stars and galaxies all the way back to the universe's own distant childhood. Tonight, you don't need to keep the Milky Way in mind to fall asleep. You don't need to remember the exact distance to Andromeda, or the precise shape of space, or whether the universe truly extends to infinity. You just need to let your breath continue slow and steady, just as it has every night of your life, without you ever having to think about it. Somewhere above you tonight, whether or not you can see the sky from where you're resting, the ancient light continues its silent journey. It needs no observer to keep moving forward. Whether you open your eyes to receive it or not, it would have reached you exactly the same way, exactly like this. And yet, tonight, you opened them, and that small, ordinary act of attention, in its own quiet way, marks a kind of completion, a long journey finally finished, within the soft darkness of your own closed eyes. Keep your eyes closed for now. Keep your breathing slow. Let every distance, Every galaxy, every billion years we measured tonight fade quietly into the background, just as a song settles into silence after the final note has been played. The Milky Way will continue to rotate just as slowly tomorrow as it has for billions of years, whether you pay attention to it or not. Andromeda will continue to approach silently at the same patient pace it has maintained for far longer than our species has even existed. And you, just as small and meaningful as every other point in this boundless structure, will still be here, right where you belong, resting within it. May your night be peaceful, your thoughts be light, and sleep come to you easily as we gently drift outward along every scale we've explored together tonight. And then, with exactly the same gentleness, drift back home to this very moment, which is entirely enough. Thank you for spending this time with the Science for Sleep Hub, drifting through scale, distance, and the ancient light of the cosmos. If this journey has helped your thoughts settle tonight, please consider subscribing so that the next quiet exploration can find its way to you. Good night. The universe is exactly this vast, exactly this patient. It will still be here when you wake up.